So, good morning, students. In our mathematics physics class, today we will discuss a little bit about the trigonometry, which is needed or essential in solving problem in vectors. So, here trigonometry deals with a right angle triangle. So, whenever you are getting right angle triangle in our problems, we'll use trigonometric ratios. Trigonometric ratios. Let me give you idea, a small idea. Whatever I need from trigonometry, that's all I'll give. The whole trigonometry will be discussed by your math teachers. And here it is direction. We are calling theta in mathematics. And the angle here is 90 degrees. Angle here is 90 degrees. So A, B, C are the vertices of right angle triangle. Are the vertices of right angle triangle. And exactly which is in contact with 90 degrees and theta is adjacent side. Is adjacent side. Adjacent side we are calling. And exactly opposite to this theta, which is not linked with the theta here. It is opposite side. Opposite side. And what is this? Hypotenuse. Hypotenuse. Now, what is the relation between opposite side and hypotenuse? The relation between opposite side and hypotenuse will be given by sine of the theta. Sine of the theta. Sine of the theta will be given by like this. Opposite side by hypotenuse. Suppose if you want to calculate opposite side, what will you do? Multiply this hypotenuse on left hand side. Hypotenuse into sine theta is equals to opposite side. Got it? Suppose you want to calculate opposite side in mathematics, in opposite side in physics, that is in number. This is also in number. You can write like this: opposite side is equal to hypotenuse into sine theta. Similarly, come on to the cos. The relation between adjacent side and hypotenuse is given by cos. That is, cos theta is equal to adjacent side divided by hypotenuse. If you want to calculate adjacent side, write adjacent side and just observe this: hypotenuse into cos theta. Hypotenuse into cos theta. So this is how we'll proceed. Okay. So for this, I'll go for one example. Just note it down. Note it down. So what we are doing here, we are using trigonometric ratios in problem solving. By doing this or by knowing these simple calculations. Now I'll go for next to proceed. Look, this side I'll go. The same thing I will repeat here. Look, this is our right angle triangle. Okay. Now I will form here right angle triangle. One force is acting on this block. This is your hypotenuse. Listen carefully. This is your adjacent side, and this is your theta, and this is your opposite side, right? This is your 90 degrees. This is what we discussed so far here. Now, how to convert this into physics? How to use? Suppose a force is acting here. 2√2 newtons force is acting on this. When a force is acting on this, it must make an angle theta with x-axis. This is theta. And this force is a vector physical quantity. And this will be resolved into components. First component is along x-axis. Second component is along y-axis. What it mean? It means that when you are pulling an object with certain force, that object moves forward in direction and rises somewhat height. Pull a kurchi or chair, you just pull that, then it will rise its legs into somewhat air and it will move forward in direction. That means when you are applying force, it acts in two directions, along x-axis and along y-axis. It is split up. It is split up into two directions, along x-axis and along y-axis by making an angle. How much force is acting along x-axis and how much force is acting along y-axis? This is completely depends on this theta value, this direction value. Is you all know this? This is 90 degrees. No, this is 90 degrees. This is 90 degrees. Just I am going to convert this into here. Like this is a vertical component of force. Can you write here? Can you write here? Can you write here? Can you write here? Yes, I can write. Now, just bring it. This is O, this is a and this is B. OA is drawn here. OA. There is no change in direction. There is no change in magnitude. This is Fx. Okay. This is OB. 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 And this is a force. This is a force. Here is the angle. The same thing I drawn here. The line which is drawn here, it just changes its location up to here. This is a Fy. I hope you all understand. You got a right angle triangle from here. Look, this is how we need to convert. Repeat this video once again and go through this. Try to understand how I drawn a right angle triangle here, a right angle triangle from this concept. How I drawn, how I select. Repeat this video and watch it. This is Fx, force along x-axis. This is Fy, force along y-axis. This is shifted here without changing its magnitude and direction. Without, look, what is its direction? It is 90 degrees with x-axis. This is x-axis, it is making 90 degrees, right? What is its magnitude? The same magnitude I drawn here. Okay. From this, what is sine theta? From our previous knowledge, our sine theta is equal to opposite side by hypotenuse. Opposite side by hypotenuse. So Fy by F. Fy by F. So what is the value of Fy? And what is that? Now we are getting that force acting along y-axis. What is Fy? Force acting along y-axis. That is equal to force into sine theta. Given force into sine. Fy is equal to F sine theta. Fy is equal to F sine theta. What is cos theta? What is cos theta? Can I write here? From this, cos theta is equal to adjacent side by hypotenuse. Fx by F. Fx by F. Look, what is Fx? Force acting along x-axis. I just asked previously how much force is acting along this. From this, we can get that. Fx is equal to bring this F cos theta. So when the force is acting at an angle theta with x-axis, then what is its horizontal component? Fx is equal to F cos theta. What is its vertical component? Fy is equal to F sin theta. Okay. What is its horizontal component? Fx. That is equal to F cos theta. What is its vertical component? Fy. Fy is equal to F sin theta. This is how, by using this, we can calculate the force which is split up along x-axis and y-axis. Okay. So whenever the force which is given to you in your problem, you will get a magnitude and you will get a theta value. This theta value varies in known values, that is theta is equal to 0 degrees, theta is equal to 30 degrees, theta is equal to 45 degrees, theta is equal to 60 degrees, theta is equal to 90 degrees, theta is equal to 120 degrees, and theta is equal to 180 degrees. And theta is equal to 360 degrees. These are the standard values of theta. So in our next class, we are going to know about the values, standard values of theta in the function of sine and cos along with a new function. Okay, just to go through this, make a note on this. You can watch repeatedly this video if you can't understand. Okay, go through this once. Tomorrow we are going to discuss a big topic, parallelogram law of vector. How many of you are not understanding parallelogram law of vector in your June and July in your 8th class? You all get ready. You all get ready to listen parallelogram law of vector on tomorrow. By knowing these basic things only, you can solve that. Okay, note it down.